Hello everyone, welcome back to my Max channel. Today I would like to share with you a very special video conducted by US teachers. Okay, the teachers will explain to you what it means by range, outlier, and how to create stem and leaf plot. Have fun!
Alright, let's take a look at this question here. Kate was given a Nancy Drew mystery computer game for her birthday. The following times indicate how long it took her to complete the game the first 5 times she did it. Okay, so here are our times. We want to find the range. Okay, so let's consider the definition of range first. So range is the difference between the highest and the lowest values in a set of data. Okay, so in this case, it's the difference between the highest and the lowest value, our value being our hours. Okay, so the time it took to complete this game. Okay, so to find this, the first thing we want to do is we want to order our data from least to greatest. That's our first step. Then we want to subtract our smallest value from our greatest value in our data set after we've ordered it. So let's do this together. So here's our times, and I'm going to just write down the numbers. As I write them down, I'm just going to cross them out to keep track of which ones I've written. Dealing with just the numbers can make things more simple, okay? So these are our values in our set of data, okay? Now what I want to do is I want to order these now. So what's our smallest number? Okay, we can see our smallest number is 2. Again, I'm going to cross it out to keep track of which ones I've included and which I haven't, so I don't make a mistake. 3 is written next. Okay, our next highest is 5. Then we have a 6, and our greatest is 10. Okay, our next step is to subtract our smallest value from our greatest value. Okay, so we're subtracting the smallest from the greatest. We're going to call our greatest G, and we're going to call our smallest S. So G minus S. Okay, here is our G, our greatest value is 10, and our smallest is 2. Okay, so we're going to take that greatest value, 10, and we're going to subtract our smallest from it, 10 minus 2. So 10 minus 2 is 8. Okay, so our range is 8, but don't forget, what are our units? Okay, we wrote our numbers down, but what are the units? The units are hours. Hours is attached to each of our numbers. Okay, so we need to make sure we include hours, and we can abbreviate hours by just writing HRS. So 8 hours is our answer. And for her birthday, the following times indicate how long it took her to complete the game the first 5 times she did it. Okay, so here's our times, and this is our data that we're going to be analyzing in this question. We want to find which of these times may be an outlier. Okay, so outlier, this is a term we first need to understand before we can answer this question. So an outlier is any value in a set of data that significantly differs, okay, from the other data points. Okay, so what I mean by this, by significantly differs, it's any number that is way higher or way lower than the other data values. Okay, so a way to find this is to use a number line or a graph. Okay, using number lines or graphs for your data can help you see which points are further away from the others. Okay, and this helps you figure out which points are outliers. So those points that are further spread out from the other points on a graph or a number line, those are the outliers. Okay, now outliers are something that statisticians use. Okay, now a statistician is someone who is constantly calculating outliers, modes, means, medians in their daily work. So these are terms that you may have come across. Okay, mode, mean, and median, outlier, range. These are all values that statisticians do for their everyday jobs. Okay, and outliers tell us if there was an error that may have occurred when measurements were taken in data. Okay? Because if you get an answer, you get a measurement that is way different than your other measurements, this gives you a clue that maybe that measurement wasn't accurate. Maybe you need to redo that experiment again. Okay? So that's what outliers are used for. So let's take a look at our data here. Okay, and what we're going to do is we're going to write these numbers down. And as we write them down, you can see I'm not including the units because this allows us to isolate exactly what we're looking at. And we're looking at the numbers. Okay? We don't need the hours attached to each of the numbers right now while we're analyzing them. Makes things more simple if we just write them out like that without the units first. Okay? So we have 10, we have 6, we have 5, we have 3, and we have 2. Now, remember what I said earlier, to find outliers, it can be easier if we do a number line. Okay, so let's draw a number line. And we're going to put our 0 here. And we want to make sure that we do this as neat as possible, okay? So you can see I'm doing a line for each point. Okay, so every second point is a 2. So we have 1, 2, 4, 6, 8, 10. Okay, now let's plot our points. As I plot them, I'm going to underline them. So we have a 10, and I'm just going to do a dot for each point. Our next is a 6. Okay, our next is a 5. That's right in the middle there between the 4 and the 6. Okay, and the next is a 3. And the next is a 2. Now remember, our outliers are our numbers that are way different or more different than our other numbers. Okay, so they may be greater or they may be less on average than our other numbers. Okay, and if you look at a graph or a number line, they're going to be further away from the other points. So if we look here, which points appear to be clustered or grouped together? We can see these points here are fairly close. Okay? Between that point and that point, there's 2. 2 points between these. That one and that one. Okay? This one, how close is it to the nearest point? Well, the nearest point to the 10 is a 6. Okay? 6 plus 4 is 10. So 10 is 4 points away from 6. But these points are all either 1 point there and there, or 2 points in those away from each other. Okay, so the 10 we can see here is our outlier, or maybe our outlier. Okay, so our answer then is our 10. Now, as I said earlier, when I was writing the numbers down, I took out the hours just to make it easier to deal with the numbers, analyzing the differences between the numbers. But we want to make sure in our answer that we're including our units. So go back, look at your units, and we can abbreviate hours as HRS. And that's our answer. So an outlier is any value in a set of data that significantly differs, okay, from the other data points. Okay, so what I mean by this, by significantly differs, it's any number that is way higher
All right, for this question, we got a 100-meter swimming race taking place, and all the competing swimmers' speeds are recorded. Right? So this is how long it took each swimmer to swim the 100-meter race. This person right here, they took 10.0 seconds. So they took it like exactly 10 seconds. All right, one thing to note with this data right now is it's given to you in form of like a decimal. So actually what that really means, it means your leaf is going to be a decimal. So your last digit is a decimal. Your first digit is just going to be single digit. It's going to be like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're actually not going to use 1 to 7, but we'll use 8s, we'll use 9s, and we'll use 10s. So first thing when you look at your data, I mean, you don't necessarily have to do this, but it's good to kind of know where your data lies, and then hopefully you can kind of, okay, well, I don't have any number lower than 8 seconds, so I'm going to start my stem and leaf at 8 seconds. Alright, so I'll just say, here's our stem. Oops, let me write that a little bit nicer. And as I said, kind of our smallest stem is going to be 8 seconds. We've got no time below 8 seconds, so I'll just throw an 8 here. Now we want to include all the leaves which take 8 seconds. It'd be nice to do it in order. We don't necessarily have to do it in order. Let's just kind of write them out. So we got one leaf at 8.1 seconds. So for our leaves, if you really want, you can write like a little decimal digit there to say it's like the 0.0 places. I don't know, maybe that helps you, maybe not. Yeah, you know what, let's just not do that. So let's just start. Anyway, systematically, we can write every single one of our data points. That's a good way to go. Let's just start from this column and go on and figure out all our things which took somewhere around 8 seconds. Or in between 8 seconds to 9 seconds. All of our data points which took somewhere between 8 seconds to 9 seconds. So first one we'll consider for going from right to left is this one right here. This thing here took 8.1 seconds. Do we have any other data points in this column which took 8 seconds? No, because this guy, they took 10.2 seconds. This person took 10.5 seconds. This person took 9.4 seconds. So none of these other people took 8 seconds, or somewhere between 8 to 9 seconds. So we're all done there for our stem being 8. Over here, do we have anyone else who took 8 seconds? Yeah, this person right here, they took 8.9 seconds. So we can write that as one of our leaves, 9. Perfect. We included them in our stem and leaf plot. How about over here? Do we have anyone who took 8 point something seconds? Yeah, we got this person right here, they took 8.5 seconds. So this stem and leaf, this will correspond to someone taking 8.5 seconds. That person right there. And over in our last column right here, we actually have 2 people who took somewhere between 8 to 9 seconds. This person took 8.7 seconds. And this person took 8.7 seconds. So we're actually going to have 2 sevens right here. We got someone who's taking 8.7 seconds and another person who's taking 8.7 seconds. So that is all of our data there for everyone who took 8 point something seconds. If you want to, you could arrange this. You know, we might as well arrange it right now. You know what, or you could just leave it. Doesn't matter, either way. Okay. Then by arrange, I mean just arrange it from lowest to highest. So it'd be nicer to actually rearrange this data and saying 1, 5, 7, 7, 9. Which, you know what, I can do just by erasing this 9 and writing it out again right here. Right, so that's arranged from lowest to highest. Okay, our next stem is going to have a value of 9. Because if we're increasing our stem by 1, you always have to increase your stem by 1 digit of whatever you're considering. So if I was considering like this stem being 80, my next one would have to be 90. Either way, you always have to just add like 1 number onto this. So no matter what your stem is, you gotta just increase it by 1 here. So if it's a 5, you gotta make it 6. 6, you gotta make it 7. 7, you gotta make it 8. If it's 8, you gotta make it 9. So our next stem we're gonna consider is all numbers which took something like 9 blah seconds to finish this 100-meter race, which is just somewhere between 9 to 10 seconds. All right, let's do that exact same thing again. Let's look at all the swimmers who took 9 seconds. Well, this swimmer in this furthest right column, this swimmer took 10.2 seconds. They took more than 9.9 seconds, so can't consider them. This swimmer took 10.5 seconds. Can't consider them either. This swimmer right here, they took 9.4 seconds. That's great. Why don't we include that swimmer right there as one of our leaves? Awesome. Okay, let's go to the next column and look at all these swimmers over here. We got 2 swimmers who took somewhere with 9 point something seconds. We got 1 swimmer who took 9.0 seconds. And 1 swimmer who took 9.3 seconds. 9.3 seconds. And going further on, we got another swimmer who took 9.3 seconds. Add them on there. And 1 swimmer who took 9.8 seconds. Throw them on right there. And we got another swimmer who took 9.8 seconds. 2 swimmers who took 9.8 seconds. And another swimmer who took 9.5 seconds. Include them right there. Okay, let's go on to do our final stem, which I know it's our final stem because all the other swimmers took 10 point something seconds. And let's go include all those swimmers onto our stem and leaf plot. So we got 1 swimmer here taking 10.2 seconds. Another swimmer taking 10.5 seconds. I'm leaving lots of spaces in between these numbers just so I can fill them up with whatever data points I have. So the data is in increasing order. Starts from the lowest here, goes higher, higher, higher. That's kind of what I'm doing. This swimmer took 10.0 seconds. Whoops, right there. This swimmer took 10.2 seconds. And we got no more swimmers left here. So yeah, we actually crossed off every single one of our swimmers, which is good. And how many data points do we have here? How many swimmers do we have to consider? We've got 1, 2, 3, 4 by 1, 2, 3, 4. So you're going to have a total of 16 data sets right here, 16 different swimmers. So that means we should have 16 stem and leaves here, which means we should have 16 leaves in total. Do we have 16 leaves? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, we got 16 leaves. So, we probably included every single one of our swimmers. And this should be our good stem and leaf plot.